Alright, I'm just gonna start. So this is the animation right here that you see. It's gonna be the one that I'm gonna walk you guys through. Um, Basically how I made it and how you could, without knowing the code, make it. Um, I I don't know. I'm just gonna this tutorial. It's gonna have the ending code is gonna be way more than the 140 character limit. But in the next one, I'll show you how to compress that down into 140. But right now, the important part is just knowing how to like turn some idea into actual visible animation. So I'm going to start up in here just trying to explain um, how exactly uh, this whole thing works. So you can see these pretty much stars, I guess you could call them. They're really just small rectangles of varying sizes, just moving right, and they're offset at different speeds. No, they're offset at different locations, not speeds. I'll go into that. Um, but right now, you just have to think of it as sort of uh, pretty much kind of random. It's not really random, and I'll show you why, but just uh, note what the animation is doing. Try and visualize that as I go through the code and explain how I'm going to make that. So I guess the first place to start is to maybe just rewrite the code and unminimize it. So I'm going to go into here. This is the code. And give me a sec as I unminimize this. And while I'm doing this, I guess I could, not really good at coding while talking, but I'll try. Um, just there's a lot in this for loop, specifically in like this three parts, so I'm just going to separate them actually, as I feel that would make it a bit easier. And there's also a lot of stuff in this. This is the main part of the program. This is what's giving the rectangles their positions, their shapes, their sizes. It's called fillRect. And if you don't know what it does yet, you can call canvas context.fillRect, give an x, a y, a width, and a height, and you can imagine it creates a rectangle at that x and y with that given width and height. Um, so that's what this is doing here, and I'm gonna actually put this up here, and I'm gonna separate the x, y, width, and height out also, because I feel like those are important enough to be left in different parts. And I might even separate these different parts into subparts, but because there's just so much in this one place, this is basically the body of the function. Everything else is pretty simple. So I'll go over I, k, I less than k, all of that first, and then I'll go into how the whole thing is going to be run. Um, I guess you can imagine I as count, I guess, of each rectangle. So if I go back into Chrome here, you can imagine each of these stars are assigned a different I value. Um, they're separate elements, and they're indexed, I guess, by this I value. So you need to think about I not in terms of like a for loop where it's indexing an array, but an index of like rectangles of I'm going to call these rectangles pixels just because they're technically not, but um, it's just easier to understand that way. Just imagine them as referencing these specific pixels, um, large pixels, I guess. Okay, let me get back into VS Code. So I'm going to separate this and just comment this as why do I have caps lock on? Not element, it's index of rect of pixel. I guess you could call it that. K is just a constant here. It's going to be used a lot of times, but there's one true purpose of it, but the reason it's used a lot of times is for compression, so I'm not going to worry about why it's compressed yet. In fact, if I rewrite this code in a separate file without all these compressions, just to explain better, um, K is only going to be used once in that case. Uh, in fact, I'm going to remove K just because for now it's unimportant to know anything about how compression works. It's much more important to know how we can take this visual idea and turn it into pixels. So I'm going to remove K just for now, and in the next video I'll add it back and explain why we need a constant like that. But if I remove K here, it should be a lot more apparent what the second line is doing. And I'll give you a few seconds to try and think it out. I'm actually bring Chrome back up. And it might help you if I explain that these pixels, I guess, the rectangles, stars, whatever I'm going to call them pixels, are used multiple times, right? They're not they're not used once. They're used multiple times through each scene. And there's only a set amount of them per each frame. So if you haven't guessed it by now, um, the reason why we have I less than 2 equals 3, 2e3, which is actually short for 2000, um, is because we need to limit the amount of stars, the amount of pixels. Because if we keep this for loop going on forever, we're going to have an infinite amount of fill rects, and that's going to cause problems. I think now is a good time to try and explain. This isn't the normal for loop you see. Usually you see I++ here in this section, but we're actually running code here. And the reason for that is I++ is run every time, right? If you have a normal for loop, just gonna do this, I less than 3, I++. This is run each iteration. So what we can do actually is we can put our code here in this place for the iteration because it's just going to be run every time, and we do want it run for every single pixel. We want our for loop to pretty much index and assign the positions for each element, each pixel. So for each of these i's, I values, we're going to assign it a different place in this one frame. We're just updating all of these pixels. So you can try and work backwards here. If you had a starry night, I don't know, uh, in your head and you're visualizing that, you can sort of imagine each star as a value of I, and you can run that loop multiple times to kind of drag each star into a separate place with the separate size. And that's what we're doing in x.fillRect here. We are running this. This isn't too important, the I equals 0, I less than 2000. This is the important part because this is how we assign the positions. And width and height, which is not as important, but specifically the positions to each pixel in our canvas. And that leads us into how we made the Starry Night thing. So before explaining the X and Y positions here, I'm gonna try and do it without using the code over here and try and explain better. So we need to separate our understanding about the x and y. We need to separate our visual intuition of the stars into really just thinking only about them on the x-axis and thinking only about them on the y-axis, because even though it might be more intuitive to think about them using like angles and length away from the origin, however your mind grasps that, we really need to pretend everything is only on one dimension for each the x and the y. So let's look back the at the stars here, the Dwight, and I'm gonna pause this actually just for a second so you can see it easier. It doesn't look that good right now, but just ignore that. Pretend each of these stars over here uh, only exist in one dimension. So our goal specifically for the x-axis, and we're not thinking about the y-axis now. We're only thinking about the x-axis for each of these elements. We kind of want them separated a bit. We want them to loop back from left to right. We want them to move left to right. And also, because we only have a limited amount of elements, because we constrain the I value, we need to make sure that this animation kind of loops itself. So the X's here, if they grow too great, they'll come back around to the left. So you can sort of imagine um, just like a bunch of, I guess you could call it like points on a number line, and they're all moving at random like starts, but they're all moving at the same speed in one direction. And once any of them hit, uh, I guess, a part or a number too far to the right, they'll be looped back around to the beginning. So that's specifically for the X. So let's try and think about how we would do that with code. So let's put our goals here. Stars separated. I should do this in stars. I'm gonna put it without comments because it doesn't matter. This is only for the X. You know what? I'm putting it with comments. So the stars are going to be separated, or the pixels, um, and they're going to be moving left to right over time. And then another thing they're going to be doing is looping back around after um, after they go too far right. And I'm going to actually draw arrows here into how we could think about this more code-based, really. So stars separated. This part, it might seem difficult at first, but we already have I values to kind of distinguish each pixel, right? So what's stopping us from using that I value as a way to separate the position on the X? So specifically for stars separated, we can just take I uh, and just add that as some offset to each one of these for loops, right? So, and if we want them to be more separated, we can assign some constant to make it so that each I is further away in value. So each I or each X, this gets translated as an offset to X, but each X is going to be further away. So all the pixels will be separated farther. uh, next, moving left to right over time. And this is pretty simple, I would say. T, we have T as time in Dwitter. So uh, this is pre-assigned for us, and we can sort of just use this really and just multiply it by some constant to make it go faster or slower. Because really, uh, if we add this as some offset, each pixel is going to be moving for each frame, and it'll move left to right because the x value for all the way to the left is 0, and the x value for all the way to the right is like 1920 or something. It depends on the canvas, but by by using t here, we can kind of increment this value over each frame, and all of these stars will be moving at the same speed to the right. And you can think about this further. How would we make them move left to right but over different speeds? Well, once again, we have I as a separator. So we can sort of just use I here to make them, instead of just offsets, we can make it multiply by t so they go at different speeds. And if that's a little confusing, it should be easier to see in the visual demo, but just really, we don't need I here. We just need t, because all we need is time over here to get them moving from left to right. Next is looping back around after they go too far right. So this one might be a little more complicated to see at first, but there is a special math operation called modulo. And really, what this does is just, if I do, for example, 7 modulo 5, it will, like a clock, it'll go through all the digits up to 5, and then it'll reset back at 0, 1. So I think 7 modulo 5, if I remember correctly how modulo works, should be, this is where it should be 1. I'm pretty sure, because starting at 0 and all of that, that's how modulo works. But you can increment this further, and like 127 is going to loop back around to some number from 1 to 5. So what we can do is mod this by some value, it really some constant, and then when the I value, pretty much where it is, because I is proportional to x here, when that gets past this constant, it'll loop back to 0. And so we can use that to loop the pixels back around if they go too far right. Okay, so I'm going to remove this here and just do mod by some constant. That's mod by some constant. And now we need to think about y. So this is really all we have for x. For now, I'm going to explain how we got the black background, but for now, this is all we have for x. And now we need to think about how y is going to work. And y is a tiny bit more complicated than x here, because we're using little mathematical tricks to get some sort of, I guess you could call it pseudo-randomness. Let's look back at Chrome for a sec. So I'm assuming, okay, it's working. So all of these y values, they're not too important because they don't change. The stars don't move up or down from their initial position, so we don't have anything using time per se. But we do have to kind of make them sort of random. And this isn't too easy to understand how to do this without prior, I guess, knowledge. Uh, but I'll try and explain. So the real code behind it isn't going to be too hard, but the main issue is the randomness because once we assign a random value based on what the pixel is, then we can just keep that value, and there's nothing to do regarding time. So let's put some goals in VS Code about how we're gonna what we need done. So we obviously need the stars separated, but this time it needs to be randomized, kind of. And that's it. That's all we really need. Actually, there's one more thing. Uh, we need the, if I go back into Chrome, sorry, uh, the stars need to be offset at first because if we don't offset them, they'll all start higher up. They'll start at the 0, which is the top of the canvas, and we can't have that because they're not moving down. The y isn't moving down like the x is. The y is going to stay in the same place. So you're going to have a bunch of pixels, and I can show you now if I take out the offset. One sec. Okay, I'm slightly dumb. We don't need them. Um, we don't speak of this. Huh. That's interesting, actually. I did think we needed them. That's surprising. Oh, we do need them. I'm not dumb. I know stuff. Or maybe I just crashed it. I don't know what I'm doing. Just give me a sec. Oh, I reversed these. Sorry. Let me remove the offset now. Okay, so we don't really need the offset. Um, as you can see, there is a little bit of kind of a gap from the bottom if we don't have the offset, but we don't. I guess I'm gonna add the offset just for now, so it's just because you'll need it later. That's like one of the things you should know for later tweets, but I'll explain why we need the offset. We kind of want all the y values to start at the center of the image, not at the top. We want the origin to be in the middle, but in canvas terms, it's all the way in the top left corner. So to combat this, we can have the x and the y uh, offsetted by half the width of the canvas and half the height. So this canvas is, its height is about, I think, uh, seven, no, not seven, it's 1080. So by making this 540, we can make it so that the y, the center, the origin, excuse me, the origin for the y values are in the direct center here. So everything is centered around this y when we use our algorithm, and the center is in the middle of the screen instead of the top left. Um, so let me just go back into VS Code. Uh, we need an offset to center, or just, we don't need an offset. We need to center y values at center of screen. And to do that, we can just add an offset. So 540 plus, and then our code, dot, dot, dot. It's just whatever happens after that. And to separate the stars randomly, uh, we're going to use a kind of pseudo-random, really short way to do it. So I kind of learned this just by looking at Twitter. I didn't really think of it, and I'm not all too sure about what it does. But if we assign our stars separated, if we, in order to separate our stars randomly, we're going to have to use I, but in order to make them, I guess, both both up, I guess, up from the center, on top of the center, and below the center, we need to use a trigonometric function, either sine or cosine. And what sine or cosine does is it limits I from 1 to -1, and you can kind of think of it as a wave. So if we have only this wave pattern, it's going to be super predictable. You can see if I go into Chrome and this is what it looks like right now, and I take out some of the things I use to make it random and just make it as sine of I, you're going to see this super predictable pattern up here that looks really like uniform, and this does not look like nature at all. And the reason why it's doing this mainly is because each of these values are they're very easy to guess, I guess you could call it, by the human eye. The wave pattern put into something like the y attribute is going to make this very predictable, I guess, this pattern. It's not going to look random because it's cyclic and it's super easy to kind of predict. And so this is where we throw in something else. Instead of just having our I here, we're going to add I times I. So I'm not completely sure how this works, to be honest. And it might be easier to see if I actually open up a graphing calculator like Desmos. So I'm going to try that out. This might not exactly work, but or I can just do it here. So if you look at sine of x, if it shows up, you can see this predictable pattern, I guess. It translates just like a wave to how the y should be positioned. The y's with an I value of like 2 will be higher up, and the y's with an I value of like 5-ish, I think, are going to be -1, so that it'll be lower down. And this it makes it very easy to predict. But if I add x times x, which is really just x squared, um, and if this shows up, you can see it's kind of, I guess, not as predictable. Just because you look at this, there's going to be a lot more change in the y value over each I. So you're going to see a lot of like really different I values that are going to be uh, kind of easy to predict. And I guess the ones here are going to be no, they're going to be hard to predict, sorry. And the ones here are going to be easier, but they're only a very small number of everything here. So really, as you look, it's becoming hard to see on Google. So with little change in the X, you're going to have massive change in where each star can be. But um, massive change as in -1 to 1. There's still a range in which stars can appear. And by doing this, we can make them kind of look random. Because honestly, if I were given an X in this anywhere here, I would not know how to guess the Y just by looking at it. And that's kind of how it is if I add it here too. I given an I value, I would not know its y. I would not know its height, I guess, or its y value. Yeah. Um, so that's what makes I times I, sine of I times I, or cosine of I times I, really useful here. And the other part, if I'm going to go back into VS Code, is not only do we need them separated, but we need them separated. That's the point. So sine only goes from -1 to 1. That's going to be like 0 offset. Uh, and we need offset. So we need to multiply this by some constant in order to make it so that the y values are much more, I guess, diverse. They're not just all near the center with like uh, differences by like a margin of 1. They need to be a margin of some constant. And that's really it for the y values. They just need to sort of be random, I guess, and they need to be centered and they need to be separated. So that's really it. Um, Width and height I can go over really quickly. And I think I'm going to go over them in the same place uh, because I use them. I use the same variable for each of them, so they're both the same. Width and height are going to be the exact same thing in my code, and you can see that by noticing that each of these stars are squares. They're not rectangles, they're squares. And so we don't need to define different width and height, we just need to define one. Uh, Really, the width and height aren't too important here. I made them a bit different, I guess, between each I value, because I felt it would touch up the look, I guess you could call it. But really, if I go back here and I assign both of this width and height to 1 instead of this, actually 1's a bit small, 10, it's not going to look all that bad. In fact, it looks pretty nice, but I just thought it would be nice to give each of these, I guess, stars different brightness, or not brightness, give them a different shape, not shape, width and height. Um, so in order to do this, we're really just gonna need to, let me open VS Code here. We're just gonna need to, our goals essentially are just stars, or shape, size, I'm getting my words wrong, sizes, size of stars. We need to make the size of stars between 0 and 10, because that kind of looks good, between 0 and 10. And you can sort of think of a function that kind of conforms, I guess, confines the values. We've used it before. It's one of the trigonometric functions, either sine or cosine. We're just going to use sine, I guess. And because the sizes aren't that visible, um, they're not too easy to distinguish. We don't need to use I times I. It's gonna just kind of not matter here, because you can't really distinguish the sizes as well as the y values. So we're just going to use sine of I to make each star a different size, because I is different for each value. And by using sine, we can find this between -1 and 1. And by multiplying this by a constant, which in this case is 9, we should make it 10 really, but to save 1 byte, I made it 9. So here, stars between size 0 to 9. It'll essentially gives us sizes between -9 and 9. But negative values, uh, in, this isn't too important, but negative values on the canvas with width and height show up as positive values. So it'll really just be anywhere from 0 to 9, which is what our goal was. So by doing sine I times 9, we can make each star different size between 0 and 9. And that's really it for our fill racked. But you can see there's one thing over here that we haven't really seen before. Ternary operator here. I'm stating that if I do this, which is our code, otherwise 0, and then for the width and height, it'll be k, which is really just like 2000. Um, so what this is doing is this is actually giving us the black background. I can take this out and also take out x.fillStyle just because it's unnecessary then, and I can show you what happens if I don't put the I in, if I don't check for I here. So let me open Chrome. It's really just experimenting to see what works and what doesn't on Twitter. And kind of just the same process. It's not all too difficult, I wouldn't say. Yeah, it's not all too difficult. Just gonna cheat a little here because I don't want to rewrite that right now. And take out fill style. Something's lagging it. I think it's fill style. This is also one of the issues because I don't take care of that with the black background because that's just, it doesn't need to. So this is what it would look like if I took out the eyes and everything. And you can see the background is white, the stars are black because I didn't use fill style, and it's kind of confusing as to why the other one does it like that. So if I go back into VS Code, I can sort of explain that. Our goal is to make a black background, white stars. So in order to do this, we're going to need to think about what would be the black background. And it's kind of not really too intuitive to think about it this way. But what if we made star 0, also known as star where I equals 0, the star where I equals 0, up here it's assigned, the first one, which means all the other stars will be drawn above that star. So this is the background star, you could call it. And what if we made it so this specific star in our code had a size of 0, or an x and a y uh, of 0. So it's centered at the top left, and a width and a height equal to the width and the height of the canvas. And what if we made this star have a color of RGB 000, which is black? Well, then this star would essentially act as a background. It would make it so that this star is the background. It's black. It's centered at x0, y0, and it has a width greater than the canvas width and height greater than the canvas height. And that would work for the black background. But how do we make the white stars? Well, we could just make it so that every other star that isn't star 0 has their own x, their own y. So star not equals 0 will have x and y of what we had before up in the x and the y. So I'm just going to put x and y. Width and height of their own, which is actually going to be just, we already know it's going to be something like SI sine I times 9, and its color is just going to be white, which is 255, 255, 255. That would work. So what we're doing up here when we add the ternary operator is we're checking I. And what this is short for is I not equals 0. Because in JavaScript, 0 means false. So if I is 0, it'll bypass this and go to the false. So what this will do is if I is 0, it'll assign it an x of 0. But if it isn't, it'll assign its own separate x value based on I, the one we defined here. And the same thing for um, y value. It will give it a value of 0 if I is equal to 0. So if it's star 0, which is the background, it'll give a y value of 0, which is what we want here. And also, we need to do this for k. Ignore the plus plus for a sec. Just think of this as I. So if I is 0, it'll give it a value of 2000. And if not, it'll give a value of sine of I times 9. And we assign this to k, which is used again, just a simple way to do width and height without having to put in more bytes than necessary. And we're also going to do I++ because we need to increment this somewhere, and this is a good place to do it. And that's it, really. That's how we got the black background and the white stars. Fill style just has some additional stuff here. The color value, which is defined by A for some reason. I don't know why I chose that. Uh, if it's star 0, we'll assign a RGB value of 0. And if not, we're going to assign 255. We're also going to add this bit here, which is not too important. It's actually really unimportant. I just made it so the stars would flicker. And it's not really that good code, so I'm going to remove it. Just a simple way to do, simple way to check if a star is 0, and if so, assign it an RGB value which corresponds to black, and if it isn't, assign a value that corresponds to white. And so by doing all of this, and also this I plus 0.4 is useless, by doing all this, we've sort of turned our visual idea into goals, turned each of these goals into code, and really all you got to do is take this code, and each of these goals will be separated by the addition sign, usually. So I times C to separate them. To move them left to right, we're going to do T times C. And to loop them back around, we're going to take all of this code, all of this X value, and we're going to percent this by some constant C. Now, all these C's are different. For now, we can just experiment with C. I've found values that work, but really, it's unimportant to know what the C is. Only when you're testing, you can do it, because that's something you really cannot visualize right there. It's kind of very hard to visualize that. But this is the boilerplate code, what our real code's going to be based off of. And actually, we do need to include all this black background and white stars, so we're going to include, I'm going to make it easier to see. So if it's star 0, we're going to give this a value of the x value of 0. That's all the x code, all the code to define the x value. We've turned it into goals, we've turned that into code snippets, we add the code snippets together, and we get our final x value. And we can compress this later, but this is the basis. And let's do the same thing for y. We want to first give it an offset of 540, and then add that to our code, which is going to be s I times times some constant. So that's all our y code. Actually, it's not. We need to add the *0 check to check for black backgrounds. Um, we're almost done here. Same thing for width and height. We are going to, this is going to be our code. If I equals 0, we're going to give this a very high value, something like 2000, so it takes up the entire screen. So the black background takes up the entire screen. And if not, we're just going to make it what a normal star would be, which is si times 9, as defined by what we've gone over before. And that's it. The black background and white stars we've defined up here in the code. And then fill style is easy enough. We've already gone over that. So really, all we need to do is plug this into fillrect, our code, mess around with what these constants are going to be, like I've done here, and that's really it. That's what this code is, and I can compare it for you. Um, this is our real code on the bottom here. Uh, let's take out this I. This is essentially the same thing. If we look at the normal code here, it's I times some constant plus t times some constant. So it's going to be I times some constant is actually, the constant worked best if it was 1. So I times 1 is really just I, and t times some constant worked best with this value, so we add these, and then we percent this by some constant, which was k in this case. So that's the boilerplate code. We do I checking for *0. Same thing for the y value over here. The top is our made code, and this is the original. We have the *0 check, 540. I minimized this to 500 for some reason. It looks better as 540. Plus sign of I times some constant. The constant here was 1e3, which is 1000, and we're just doing times right here, times sign I times I, and then if it's *0, we'll give it 0. With height should be pretty much exactly the same. I have the star check over here. We increment in here too, just because to save bytes and all that. It's not important now. I can actually remove this increment just so it's easier to see. And this is the same thing. We star check for *0, the background star, and if it is, we'll give it a value of 2000. And if it's not, sign of I times 9 for the normal stars, which is the same thing as up here. And that's it. That's the code, and that's the process for Dwitter, especially for Dwitter, of taking that visual idea that you kind of think up in your head or you look at as something in nature, whatever visual idea you have. It's unimportant, but whatever visual idea you have and how you break that up into code and how you combine that code back together to make a dweet, and that's the basis of JavaScript animation. And that's going to be it for this tutorial. In the next one, I'm going to explain how we can better compress our code to fit it under the Twitter 140 character limit. Uh, I don't think that part's as important as this one. This one is it's much more necessary to know how to break that idea into code than it is to compress it, because compression is usually universal. It's the same tricks every time, but the idea behind animation, JavaScript animation, is really this process of breaking your idea into goals, and those goals, turning those goals into code, combining that code, and that's it, really. That's your animation. So I'm gonna stop for today, and hopefully tomorrow I can release the second part where I teach you how to compress this code. But as for now, that's all I have today. Thank you for watching. Please, if please, just please, subscribe. I really put a lot of effort and time into these videos, so I just want my work to be for something, I guess. Uh, it's your decision, but like it would mean a lot. So thank you for watching.